So this is the last part of chapter 8 that I'm going to finish up with, and it's talking about what we call sigma and pi bonds. All this is going to be what I call additional vocabulary terms, things that you need to be familiar with. It kind of overlaps a little bit with hybrid orbital theory as well. So sigma bonds are what we call a single bond. So they're no different. We're just going to use a different vocabulary term. And what it is if you think of the hybrid orbitals, it's what I was drawing that other video. It's the overlap of two different orbitals, and so that is where the electrons are being shared. Okay, so that is what we call a single bond with that overlap end to end. Pi bond is a lot harder to think about because you have a double and a triple bond in that thought process. It is what we call a sideways overlap. Okay, so it's two pi bonds that kind of fold in on each other. And there's going to be an animation I'm going to have you watch that kind of goes through it because I can't really draw it on a piece of paper very well. So I'm going to give you some background notes, and then you're going to have to go watch that. It's a YouTube. It used to be an animation, but now it's just a YouTube clip that I'm going to have you kind of walk through that because, again, the pi bond is really hard to understand that it's like an overlap that you have above and below the plane. So there's going to be three molecules that this animation is going to have you look at. One is C2H6, one is C2H4, and one is C2H2. So I just wrote them down here so that you could see them. So if you want to copy this in your notes before you go into the animation, I think that would be good. Again, this one is what we call an alkane. This is an alkene, that's an alkyne. This has single bonds, this has one double bond and single bonds, this has a triple bond and some single bonds. So what it's going to go over is this idea of sigma and pi bonds, okay? So any single bond, okay, any single bond that you have is going to be considered a sigma bond. If you have a double bond, any double bond in a structure is going to be one sigma and one pi bond. And then a triple bond is going to be one sigma and two pi bonds, okay? So with the animation, what it's going to do is kind of walk you through how to identify these pi bonds, especially because those are kind of the harder ones to kind of understand. And these are pi symbols. Hopefully you could read my handwriting. So if I take, for example, C2H6, all right, I'm going to look at each one of these single bonds. Okay, so I have 1, 2, 3, 4, 5, 6, 7. So I have 7 sigma bonds in the whole molecule. Okay, 7 sigma bonds. If I go to C2H4, I have 1, 2, 3, 4 sigma bonds. But in a double bond, okay, this bottom one is the sigma, the top one is the pi bond. So I have a total of 5 sigma bonds, and I have 1 pi bond in this whole molecule, okay? And then C2H3, I have 1, 2, 3 sigmas, okay? Because again, the bottom one we could say is the sigma bond. And then you have 2 pi bonds, okay? That's a pi bond, that's a pi bond. So I have 2 pi bonds with a triple bond. So anytime you're looking at a carbon-based molecule, what you're doing is trying to see how many sigma and how many pi bonds are. So let me draw a molecule. And let's see if you could count up how many sigma and how many pi bonds you have in it. Okay, so draw this molecule. I'm going to pause the video and see if you could count how many pi bonds and how many sigma bonds you have. All right, so I'm going to count my sigmas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sorry. 14 sigmas. I forgot that hydrogen down there. 14 sigmas. And then this double bond, I counted as 1 sigma and 1 pi, so I have 1 pi bond. I have 1 pi bond. So that's going to be how the question is asked of you. Here is a molecule. How many sigma and how many pi bonds do you happen to have in that